Let's do some more problems. Okay, first off, status is to do. Difficulty, is there any easy? Oh, shit. See, I can't say I've done all the easy ones if there's easy ones that I haven't done. So let's take a look here. Okay, Leetcode 3852. You are given an integer array nums. Consider, all pairs with distinct values x and y from nums such that y is less than x, and x and y have different frequencies in nums. Among all such pairs, choose the pairs with the smallest possible value of x. If multiple pairs have the same x, choose the one with the smallest possible value of y. Return an integer array x, comma, y. If no valid pairs exist, return -1. Okay. Okay, so x and y have different frequencies, so we need to know the frequencies. For frequencies, we're going to use a counter. We're going to say C equals counter of nums, right? We're going to say nums.sort because x has to be less than y. Then let's say for I in range length nums. And then we'll say for j in I plus 1 comma length nums. And we're supposed to return the smallest possible value of x, right? So if now it's sorted, so we're already looking at the smallest one. So if I equals j, then continue. Right? Now, excuse me. If multiple pairs, choose the pair with the smallest possible value of x. X and y have different frequencies. So if they have the same frequency, then they won't work. So C of I equals C of j. Then continue. You know, we could probably do it like this. And if that's not the case, then we return I, comma, j. And if we don't find it, then we return -1, comma, -1. Run. The hell is the 0 coming from? Oh. That's pretty dumb. Yeah. I index, j index. I equals nums of I. J equals nums of j. All right. I think I did a pretty bad job there. Now, what in the hell is going on here? I sorted it, right? I was not expecting a problem like this. C of I, C of j, right? I'm going to say print C and then print I, comma, j. And C of I and C of j. Let's figure out why this is not working. Okay. So it didn't iterate at all? Five, 4. How incredibly odd. Print C, length nums, I guess. nums. Okay, so length is 3. So 3. Oh. Dumb. That was pretty dumb. Alright. Can't change horses in midstream, right? Okay, that sucked. Okay, Leetcode 3856. Trim trailing vowels. You're given a string S that consists of lowercase English letters. Return the string obtained by removing all trailing vowels from S. A, E, I, O, U. Okay. Well, gotta get rid of all of them. While S and S -1 in A, E, I, O, U. Let's say S equals list of S like this, S -1, and then S dot pop. We get rid of the vector and then we reconstruct it. Join S. Right? Yeah, let me go get a drink. And we're back, but I'm gonna have to take my tea bag out. But I think we can manage. Let's see, problems here, difficulty, medium, order by, acceptance. Oh my goodness, some of these have very high acceptance rates. Okay, oh, premium, interesting. Okay, 3860, unique email groups. You're given an array of strings, emails, where each string is a valid email address. 2 email addresses belong to the same group if both their normalized local names and normalized domain names are identical. The local name is the part before the @ Okay, local and ignore all dots. Okay, whatever. Ignore everything after the first plus if present. Convert to lowercase. The domain name is the part. Okay, return an integer denoting the number of unique email groups after normalization. Okay, so Alex, huh? Local, normalized domain, final email. So the answer is 2. Okay, this is pretty friggin' easy. Okay, so we're going to have some sort of a normalization function, right? It's going to take a string. And then the local... Okay, so everything has exactly one @ right? Exactly one @ So local domain equals s dot split at tuple tuple. There we go. Okay, so ignore all dots. So LO equals LO dot replace dot with nothing, right? Yes. And then ignore everything after the first plus if present. LO equals LO dot split plus first part. Convert to lowercase. LO equals that. This is pretty dumb. This definitely should be an easy. The domain name is the part after. So you leave it the same, basically. You don't mess with it at all. DO, we can just... No, we can't. Oh, that might be a reserved word. Do. Dot dom equals dom.lower, and then return. Well, we'll say lo. No. We don't need to combine it. There's no benefit to combining it. Okay, and then just return counter of n of I for I in emails. Well, no. It wants to know how many unique ones there are, right? So it's the length of the set. All right, sweet. Okay, let's see here. Number of unique emails. Are these all going to be premium? Let's see here. Premium content. Premium is non-premium. 83.2. So these ones are all premium. Okay, whatever. All right, total distance to type a string using one finger. Interesting. You're given a string S that consists of lowercase English letters only. Return an integer denoting the total distance to type S using only one finger. Your finger starts on the key A. The distance between two vowels is... Okay, so it's a Manhattan distance then. Okay. We'll say keys equals, right, dot replace space with nothing, and then dot split like that, and then we'll have positional mapping. Mapping equals... just regular. How do you add to a dictionary? Is it put m dot put a c a what the hell is a 1 2? I don't know. I usually use default dicts. Okay, dict object has no attribute. Put. What is it? Oh my god. Print dir of m. This is like basic shit I should know. Okay, there's got to be something like add or let's see. Clear copy get pop item update? Is it update? Can't you just do this? Yes, you can. I knew that. I was just testing you. Yeah, I'm an idiot. Okay, so let's go. For I in range length keys, for J in range length keys of oh shit. That ain't gonna work. Keys of I was thinking that it was a square array. Almost did something dumb there. Yeah, then we're just gonna say M of keys I equals I comma J, right? Sounds good to me. And then let's make sure that it's right. 0 so we don't get the red text. We got something. Tabs. Tab. What is it angry about? I have no idea why it's angry. key error. Keys of I of J, I guess, is what I wanted. Key error Q. Okay. 0, 0, 0, 1. Okay, it looks good to me. Now we're just going to trace our starting position is, well, we'll do x comma y equals first row, 0th column, right? And then we'll say for C and S, C and T equals 0, and then C and T, well, let's do next position is I comma J equals M of C, like that, and then we'll just say C and T plus equals absolute value of I minus X plus absolute value of J minus Y, and return C and T. Interest. Oh my God. I forgot a very, very obvious step. Blame it on my tea bag. Distracted by my tea bag. Do you see the step that I missed? Okay. And that does it. All right, cool. Beats 100% even with all this bullshit. Okay, whatever. Whatevs, man. Median of a binary search tree level. That's interesting. You're given the root of a binary search tree and an integer level. The root is at level 0. Each level represents the distance from the root. Return the median value of all node values present at the given level. If the level does not exist or contains no nodes, return -1. The median is defined as the middle element after sorting the values at that level in non-decreasing order. Wait, it's not, it's a binary search tree. They're already sorted. The hell are you talking about? Sorting? Piss me off. If the numbers is even, return the upper median, the larger of the two. Okay, whatever. Okay, A equals A for asshole. I don't know what that means. I don't know why I said that. Okay, def R of N, like that. Now, if N is none, then oh wait, we need a level. N comma L. Okay, if N is none, return, just return, that's fine. Okay, if L equals, well, desired level, I guess. You know what, we should have this count down to 0. If L is equal to 0, then in that case, we're going to say A dot append N dot val and return. Otherwise, we're going to recurse N dot left comma L minus 1 and N dot right L minus 1. And then we'll just call it like this. Excuse me, our root of level. That way we don't have to make the level variable available inside. That way we count down to it instead of up to it. Same basic idea, right? Okay, now, if length of A, wait. If not A, return, what did it say? Return -1. if length of a, so if it's odd, so let's think about it. If it's length 1, then we'd want 0. If it's length 3, then we would want 1. Yeah, so it's just return a length of a integer by 2. Yeah, so they want us to go up 1. So if it were length 4, then they would want, well, now I'm confused. If it's length 2, they want the upper one. So, yeah. It's the same. All right. Beats 59%. Well, it's hard to beat that. I don't know what that means. Okay, let's come back here. Where were we? Oh no. Lost my place. Problems. Okay, I'm getting too many tabs open here. Good indices in a digit string, right? You're given a string S consisting of digits. And index I is called a good if there exists a substring of S that ends at index I and is equal to the decimal representation of I. Okay, so it can only be up to 10 then, right? Output 11. 11? An index I is called good if there exists a substring of S that ends at index I and is equal to the decimal representation of I. Oh, that's interesting. That is interesting. It's almost like a try, but backwards. Well, no, because the index location still matters. At index I ends with I. Okay. So I think we need to do all of the different lengths of I as we scan, right? S of length is at most 10 to the 5th. So 10 5th is just 100,000. So yeah. That's not really a lot. No. Hope you're not getting any crazy ideas. Okay. I was thinking of something crazy. Okay, so for I in range length of S, right? Now we're going to have a running number like this. Okay. Running number is going to be, well, 0, obviously. And then it needs to be n times equals 10, n plus equals int of s of I, right? And then we need to keep it from getting too big. So n mod equals 10 to the 6, so a million. 2, 3, 1, 2, 3, right? Okay. And number of digits. Okay. Num digits equals and then next digit. Yeah. Num digits. Next multiple. Let's do it like that. Multiple equals 10, right? And so when we hit the next multiple, so if I equals next multiple, then next multiple times equals 10, and num digits plus equals 1. Now, is that necessary? Now, that's a good question. Next multiple is 10, right? Which is exactly what we would want to mod it against. To get the last one digit. Let's see. I don't think we need the num digits. Let's just get rid of it and see if we can work with this. Okay, so now it wants to know. Okay, so ret value is going to be equal to r, and we're going to say if n mod next multiple equals I, then in that case r dot append I. All right. Okay, yeah, that was pretty easy. That would have become n squared pretty quickly if you were like trying to do like string searches or something. That I even mentioned to try is a little bit ridiculous. Okay, let's go back to the problem list. All right. Did this update? Minimum total sum with threshold constraints. Okay, you're given two integer arrays, nums and threshold, both of length n. Starting at step equals 1, you perform the following repeatedly. Choose an unused index I such that threshold of I is less than step. Okay. If no such index exists, the process ends. Add nums of I to your running total, mark index I as used, and increment step by 1. Return the maximum total sum you can obtain by choosing indices optimally. Threshold is less than step. Threshold. Choose an unused index I such that threshold of I is less than step. Okay. Yeah, it would help to look at the inputs there, Luke. Okay. Choose an unused index I. Okay, so you just... We're just going to step through each of these, right? Choose an unused index I. Mark index I as used and increment step by 1. So we have to go in this order. Threshold I is less than step. Am I missing something? Like, I feel like I'm missing something. I feel like I have one too many variables and I don't know what to do with it. Okay, starting at step equals 1. We have that one down. Step equals 1. Let me get my coat off. It's hot in here. Okay, step equals 1. Choose an unused index I such that threshold of I is less than step. So we don't mark the thresholds as used. We can repeatedly use thresholds. If no such index exists, the process ends. Threshold has to be lesser than, but as step is going to be getting bigger. So what causes a termination? Choose an unused, that's important. Unused index I such that threshold of I is lesser than or equal to step. If no such index exists, the process ends. So we're marking them. Mark index I as used and increment step by 1. Add nums of I to your total. So we don't choose which nums of I, it's just, oh, that's dumber than I thought. So threshold of I has to be lesser than or equal to step. I feel like I'm being dumb here. And let me guess, it goes up to 10 to the 5th. So I guess on like some sort of a superficial level, we're saying which of these nums is available and which of these do we want to spend. It seems like we want the biggest one over here. Maybe we could work backwards. I can't imagine how these interplay though. What choices are there? Threshold of I is lesser than or equal to step. You see, step is going to be getting bigger, so anything that was available is going to remain available, right? And these will have paired values. I think that's the first thing we need to do. We need to say paired values equals list of zip of threshold comma nums, like that, right? Let's not have that long of a variable in print. PV return 0. Okay. All right, so 5, 1, 1, 10. Now, we want threshold is lesser than or equal to step. Okay. I think I got it now. So pv.sort step equals 1. Let's put it down here with what we're going to be doing. All right. So just while true. Step plus equals 1. Now this may potentially open up new locations. So we're going to say, wow, we're going to have, this is going to be a heap. No, it's just going to be shorted, but there will be a separate heap like this. Okay, so once it becomes available, then it's permanently available until we run out of locations. We're always going to use every location, though. Because if it's available, then we're going to fucking use it. No, because multiple might come available at the same time. Yeah. Yeah, if multiple come available at the same time, then we're going to use every single one of them. And step will just increment accordingly. Right? If there's 3 that come unlocked, then we want to use them. No, not necessarily. No, because step might increment and it might give us a bigger number to use later, so we're going to choose that one instead. Right? Threshold is lesser than or equal to step. What if the threshold is really, really high? Then we really could run out. Yes, but if the threshold is really, really high, then that's not one that we're going to use. I think you're overcomplicating it. No, we're sticking with the plan. Okay. Step plus equals 1. While step while PV of 0, 0 is lesser than or equal to step. So every single one that's available, right? Now in this case, we are going to say, well, we don't care about the threshold anymore, and then the individual value is going to be pv.pop0, like that. Then we're going to say heap push h, v, right? Now, for each incremented step, we only ever add one thing, and we want that to be the maximum. Aha, so this should be negative v. We want that to be the maximum, so we're going to have, yeah. If not h, then break. We are done. And TOT is 0. If not h, then break. Otherwise, TOT, what are you doing? Minus equals, I guess. Heap pop of not v, of h. And then just return top like that. List index out of range. Oh, that's interesting. Yeah. While PV and well, all right then. Okay, beats 5.9%. Well, I guess that's one way of saying that my solution sucked ass. Heap push. Hey, I was just following the instructions. Bitch. Okay, minimum cost is split into ones. Minimum cost to split into ones. You're given an integer n. In one operation, you may split an integer x into 2 positive integers, a and b, such that a plus b equals x. The cost of this operation is a times b. Return an integer denoting the minimum total cost required to split the integer n into n ones. Is there any reason you wouldn't just always choose the minimum split? N is 500, huh? n is 500. Return an integer denoting the minimum total cost required to split n into n1s. So 1, 2, 3. Okay, and so then each one has to recursively split, right? So cost to get it to ones. I mean, this feels like dynamic programming, but I don't know. Yeah. 500 to the third should be our max. Times n plus 1. Right. Now, dp of 1 equals 1, right? Then for I in range 2 through n plus 1. So yeah, what is the best? What is the best? What an excellent question. So you would never do we have to try every single combination? If we can get it down to 2 numbers, no? Okay, I don't think we can do that, right? I mean, 500 times 500 times 500 is 125 million. Right? Well, okay, let's just code it in the inefficient way, and then we'll see. Okay, so we need 2 numbers for j in range, well, honestly, 0. No, because it would have to be something that you were adding together. Yeah, so 1, 2, I guess I, right? It wouldn't be equal to I. It would have to be 1 less than I, so yeah. So bottom number is going to be j, and then top number is going to be I minus j, and then cost is going to be bottom times top. Am I doing that right? Okay, split it into 2. A plus b, assert b plus t equals I. Well, I mean, of course it does, right? Yeah, that's a little dorky. Then the cost is going to be b times t, the cost of the operation. Okay. You know what? This isn't too bad. I thought it was n cubed and it's just n squared. So that should be doable for a small number like this. Okay, and then it's going to be 2 different numbers. Whoa, this should be 0, right? Because once we have a 1, then we're done. Yeah. Then these numbers should be less than I. Okay, so the cost of this specific operation is this, plus dp of what? well, dp of b and dp of j. No. B and t. That's what I wanted. Yeah. And so this is going to, well, we need to compute the best cost first. So best cost equals 500, not times 3, to the third power. And best cost equals min of best cost, comma, c, and then dp of I equals best cost. And then once we've done everything, then just return dp of n. I didn't reuse n anywhere, did I? Nope. Yeah, that was fun. I haven't done a dp problem in a while. Oh, shit. Okay, if n equals 1 or n equals 2, return n minus 1. If n equals 3, return n. Let answer equals 1. If I equals 4, then I is less than or equal to n. I plus equals 1, answer plus equals 0.5. What in the hell? Don't understand why it works. Could you explain? All right, I'm sure he will get right back to me. That's a joke. I'm pretty sure he will not get right back to me. Okay. Lowest common ancestor of a binary tree, part 3. Number 3, lowest common ancestor. Lowest common. You're given 2 nodes of a binary tree. Oh, okay. Return their lowest common ancestor. Each node will have a reference to its parent node. The definition for node is below. All right. According to the definition of lowest common ancestor on Wikipedia, the lowest common ancestor of 2 nodes, P and Q, in a tree T is the lowest node that has both P and Q as descendants. The lowest node. Oh, common ancestor. Lowest common ancestor. Okay. So how do we know which one's higher? What I mean is where we allow a node to be a descendant of itself. That is how we know. Okay. Okay, we would want the lowest one that's a match from both, right? I think we start from P, we make a list, and then we start from Q and we work up. Yeah, we can do that. Okay. And obviously you could eventually hit the root. So we're going to say scene equals set, and I'm assuming that this is hashable. I assume. Okay, and we're going to say n equals p, right? Okay, there is a rule that says n p does not equal q. Okay, cool. So n equals p. Now, while n is not none, n equals n dot parent, and we're going to say scene dot add n, and then we're going to say if n equals q, then return q, because I mean, just obviously if we hit it, then it's the lowest common ancestor. Okay, and then we're going to scene dot add n, and we are going to have n equals q. God, cars are loud. Not all cars, just some of them. I guess that's a motorcycle. N equals q. And this is going to be similar. Well, n is not. No, this is not going to happen. Scene. Okay. If n in scene, then it's going to be the lowest. We'll return n. And I guess that's it. P and Q exist in the tree. All node.value are unique. Oh, okay. Okay, that was easier than I expected. Even though I had never heard of a lowest common ancestor, not hard to figure out. Okay, let's see here. Delayed count of equal elements. You are given an integer array nums of length n, and an integer k. For each index I, define the delayed count as the number of indices j such that I plus k is less than j is less than or equal to n minus 1, and nums of j equals nums of I. Return an array ANS where ANSI is the delayed count of index I. I did not understand a single word that I just read. I feel like I've just wasted my time. All right, let's see if the example makes it clear. Input nums equals 1, 2, 1, 1, and k equals 1. What is k? What is k again? I plus k is less than j. Okay, for each index I, length n. Okay, so there's an index of numbers, right? Nums of I equals nums of j. Okay, so it has to do with where they're equal. Return an array ANS where ANSI is the delayed count of index I. Okay, so possible j, 10 to the 5th. I have no idea. All right, let's do some shit here. Nums of j equals nums of I. So obviously we are only looking at indices where things are the same. So we will say d equals default dict list, I guess, for I in range length nums, and then d of nums of I dot append I, right? So we're just looking at the indices. So for each index I, the number of indices such that I plus k is lesser than j. I plus k is lesser than j. Which is, okay, this part can be ignored because this is implied. And they're already sorted. So nums j equals nums I. Okay. So nums of I is 1, 2, 1, 1, 1, 2, 1, 1. Possible j. Okay, so 0, not 1, 2, 3. Okay, and I plus k is lesser than j. So j is going to be bigger. J is bigger. So up to 2, right? I think this is what it wants. R equals none. For well, yeah, times length nums, right? And then we need an insertion point. Actually, I think that we can do this inline. No, we cannot. No, can the hell not. ARR in D. For ARR in D dot values. Okay. If length ARR equals 1, then R of ARR of 0 equals what? We don't need a special case for 1. We don't. I mean, we just don't. Okay, so we're going to have 2 counters, right? We're going to have I comma j. And I is going to be equal to 0, and j is going to be equal to 0 initially. And then the indices are allowed to go as high. I plus k is the limit. So we want to increment j until that would be violated. So, no, overloading I and j in this manner is going to be confusing as shit. Let's call this x and y. We don't need that. Okay, and then ARR dot append something that's going to be always bigger. So what is the maximum k? K is, yeah, so 10 to the 8th or something. I don't know. Something so big that it's never going to hit. Okay, and then we need to look at every possible. Let's do it like this. Let's say y equals 0. Okay, and then we're going to say for I in range. Well, no, not even in range. Just for I in ARR. Not the last one. Okay. And then we need to advance y as much as possible. So, while ARR of y plus 1 is, let's do this twice. While ARR of y plus 1 is greater than okay, so long as I plus k is less than ARR of y, that means it's still legal, right? And we're going to increment y, which is going to push it off the end, and then we will decrement y so that it's legal again. We'll make sure that we didn't screw it up. I plus k is strictly lesser than ARR of y. And you know what? We'll even put in the extra condition that doesn't matter. ARR of y is less than or equal to n minus 1. And what is n? What is n? N is the length of nums. That was dumb. Less than or equal to was dumb. Okay. Now, we should be able to get the span, right? Now we can go R of I equals Y minus I. Not, oh God. We'll see if there's an off by 1. If there is, it'll be trivial to fix. Okay, nums 111. Assertion error. I was not expecting this. So, I plus k, ARR of y, length of nums, y, and ARR. Let's find out why it's throwing this assertion. ARRY is not defined. Okay. Very, very big. Very big. But this should have reverted it, right? I plus k. K is never equal to 0, is it? K is equal to 0. That's what's happening. It's, I didn't realize k could be equal to 0. If k is equal to 0, then the index is never going to be the same. Yeah. If k equal, I didn't know that could happen. If k equals 0, return 0 times length of nums. So we got to the bottom of that. Alright. Still messing up. So 10 million or whatever that is. No, 100 million, excuse me. And then 4, and then -1. You see, it shouldn't ever be -1. While I plus k is lesser than okay. I don't know why this is happening, but if y is less what the hell is going on? Okay. Oh! Whoopsie. Was that the problem? Expected an indented block after if statement. That was not the problem. Okay. You know, you're really starting to piss me off. All right. Okay, so for I in range ARR length ARR, right? Okay. Max value, max acceptable value is ARR of I plus K minus 1. Right? That's what it is, right? So max J is going to be bisect left, and we know that all of these values are unique, right? Is going to be bisect left of error, comma, max value. Okay. Now, if MJ equals length of ARR, then MJ minus equals 1, right? We want something that's in range. Okay. Now, while ARR of MJ is greater than or equal to? Yeah, if this value is too big, then we need to decrement it. So if it's greater than or equal to ARRI plus K, then MJ minus equals 1. Now we have a range, and we can say R of ARR of I equals ARR of MJ minus ARR of I. Took something that should be order, you know, n and made it n log n, but if it gives us the right answer, then that's fine. Okay, k equals 1, 0, 0, 0, 0, 0. Okay, we need to find out what is happening here, so... Okay, so we get there and we have 0, 2, 3, right? And it should come in here and it should look for I plus K has to be less than, or was I looking for things that were, was I looking the wrong way? So it wants the remainder of the array, right? So length of ARR minus that plus ARR1 minus 1, right? Yeah, J has to be big enough. It has to be big enough. Okay. Okay, so minimum J value equals that. If length of ARR equals 1, then continue. Obviously, there can't be anything in that case. For I in range length of ARR, minimum J value equals ARR of I plus K, right? Yeah, because it has to be less than, not less than or equal to. So if J is not higher than that, so next J index equals 0. Now if I is greater than next J index, then next J index equals I plus 1. I don't think that this is right because I misunderstood the question. Nj of I equals I plus 1. Because if I is 0, then it still has to be 1 higher. Nji equals max of Nji, comma, I plus 1. Right? Minimum J value. Now, while J plus 1, while J is lesser than length of ARR and ARR of next J index is lesser than minimum J value, then next J index plus equals 1. Right? And we need to know the items that are located there is going to be length of ARR minus next J index, and that's what we're going to return for the index of I. Right? J is not defined. Null. And how in God's name do we get null? That's how we get null. Now that 1 is interesting, right? If NJI is less than length of ARR, and ARR of NJI is lesser than minimum J value. All right. I didn't leave a print statement in there, did I? Well, that really took my energy away. Feel kind of defeated, actually. Alright, are we almost through the premium? Jeez. Leetcode 3294. Convert doubly linked list to array 2. You're given an arbitrary node from a doubly linked list which contains nodes that have a next pointer and a previous pointer. Return an integer array which contains the element of the linked list in order. Alright. While node dot previous is not none. Well, okay, there's at least one node that's given. Node equals node dot previous. Okay, ARR equals that. And then while node is not none, ARR dot append node dot val and node equals node dot next. Return ARR. Why is it taking a long time? That's kind of weird. All right, that was pretty easy. Design an expression tree with evaluate function. Given the postfix tokens of an arithmetic, no, fuck this. Come on. I want to do one that's fun. Longest common subsequence between sorted arrays. They're all premium. Why are they all premium? Given an array of integer arrays where arrays I is sorted in strictly increasing order, return an integer array representing the longest common subsequence among all the arrays. A subsequence is a sequence that can be derived from another sequence by deleting some elements, possibly none, without changing the order of the remaining elements. The longest common subsequence in the two arrays is 1, 4. How many arrays are there? 100, 100, 100. Oh, interesting. Interesting. Okay. And it has to be in every one of the arrays. Okay. All right. This sounds like a try to me. So we're going to have class try node. And it's going to be self dot children equals default dict of try node. Right? Self dot children. What's a children? Children. And then it's going to be path count equals 0, I suppose. And then we're going to have head equals try node, like that. And we're going to have to start from each and continue from each. Or are we going to have to almost like we're going to have to attempt or skip, right? Is that the wind, or is somebody breaking into my apartment? I think it's the wind. Oh well, if I die, I die. Alright. Head equals trinode. It's the skipping. It's the skipping that's confusing me here. Because we're going to pick up from all possible endings, right? Yeah, we're going to have... okay, active... Okay, so for ARR in arrays, it is a list of lists. Now, inside of here, we are going to have active nodes, and it's just going to be head to start. And then in each case, we can either add to it, or we can start a new one, right? So we leave it, we add a new one, how in the hell is that going to work? Wait, we're going to have 100 factorial? I mean, that's not going to work. Okay, in order to jump to a node, we would have to... Okay. We would always want to jump to the nearest node. Right? I don't know how to do it. I mean, if I tried to construct this trie, it's going to be 100, or it might be 99 factorial, but it's the same thing. It's computationally impossible. We'd say from each starting position. Is there a trick? Arrays.length. Every value is less than 100. I feel like that's a hint. Oh, this is it. Arrays of I is sorted in strictly increasing order. Strictly increasing order. So every single one of them has to be increasing. That really does simplify the problem a lot. Okay, so the longest, well, no. Are we going to try to parse it? Yeah, like if they don't all have a 1, then we get rid of the 1, right? And then if any don't have a 2, then we get rid of the 2. Oh my god. Oh my god. I feel like such an idiot. Okay. Okay. For ARR in arrays. Running set equals set of arrays 0. God, I really feel stupid right now. All right. RS and equals, it's just if they both share the set, because they're already sorted. So we already know they're in the right order. Get it? Return length of RS. Oh, it does want the, it does actually, okay, that's fine. List of sorted of RS. All right, there we go. Oh my god. Okay, I think that's enough of that shit. Okay, good night.